Good evening, everybody. So I'm Sumesh. I lead the public cloud and private cloud engineering in PayPal. So before getting into the DevOps journey, I will talk a little bit about the cloud engineering at PayPal, the scale at which we are operating the cloud, kind of a high-level view about what are the numbers, the high-level numbers of the data centers, availability zones, a number of VMs, number of applications, etc. Then we will provide a context about why we went into a DevOps model for some part of the stack, and what and how we chose to go into a model which makes sense to PayPal. And this is not a generic industry term like DevOps, and why it makes sense for PayPal to do that, and how we took the principles of the DevOps and how we applied that in PayPal. DevOps at PayPal, we'll talk about that. So when we started off this journey, we had several initial focus, and so there are several intense focus areas. We'll talk about that also. And we'll give why we chose those initial focus areas. And the focus areas were related to access management, vulnerability management, self-service security patching, self-service provisioning of the applications and VMs, self-service monitoring, and how the visibility for both the dev and ops is benefiting PayPal availability and security, agility and all. We'll conclude the discussion with some of the suggestions from my side on how you can start if you haven't started the DevOps journey. So with that, so please keep any questions, please raise your hands. We will take the questions during the session itself, not waiting to the end of the session.
Every server is owned by PayPal, no external.
What is that?
Every server you have is owned by PayPal.
That's right. So we run both in, okay. The question here is whether every server is owned by PayPal, or is that servers are owned by other cloud service providers like the public cloud. That's the question, right? So we have our own servers, on-prem data centers, and we also operate in public cloud. We definitely chose multiple public cloud providers. We have a significant percent, more than 10% of our compute in public cloud. Around 90% of our compute in on-prem cloud.
Yeah, this is all on-prem cloud, what you're seeing.
So just getting into the numbers, our data centers, the cloud is in 3 regions. And we divided that 3 regions into around 12 availability zones. You can think about per region. In one of the regions, we have around 5 availability zones. Another region, we have around 4, and the third region, we have around 3 availability zones. And between all these availability zones, we have close to around 70,000 servers. And we buy the servers from multiple vendors. And we are running OpenStack on top of some of these servers. Around 40% of the servers are running OpenStack. We are making them as hypervisors. And in that hypervisors, we are running around 230,000 VMs. And in PayPal Dev, just to give a scale, around 4,000 plus engineers are developing the code on a daily basis. And they're working close to around 3,500 applications. And that application stack are anywhere from C++ older versions to the Scala. So we have multiple frameworks in Java, Scala, Node.js, Cube, and all. Python, we have multiple, all the stacks. It's a full stack shop. And in the dev environments where we are using it for testing CI build systems, we are running in 2 availability zones. In dev specifically, we started running off with the public cloud. Even in the on-prem, we have close to around 1,000 machines, physical, and around between the public cloud and on-prem, we have around close to around 40,000 VMs. So this is the cloud. In the cloud, we run around 3,500 applications, and between these 3,500 applications, within the data center, we have close to around 70 billion hits, the service hits in a day, and the scale is pretty high, right? And from an OpenStack perspective, we are one of the biggest installation of OpenStack across around 12 availability zones plus one in Dev, 13 availability zone. We are one of the biggest, largest installation in the world. We're not the number one, but we are one of the largest ones in the world. So anything that gives us a context about anything which we do in the cloud, in PayPal, it is based on some drivers, and majority of those drivers, the key drivers for anything which we decide, you have seen the scale from the previous slide, and the scale and economics related to that. There is a cloud economics related to that. That drives any strategy which we are taking forward in the public, in the cloud strategy. So most of those, PayPal as a business, we grow around 20% to 25% with the public information per year, and the infrastructure also grows in similar kind of numbers, right? And growth and modernization of the fleet is a major driver, and how fast we can get into the growth with and support the business along with that. That is one of the drivers. And as we grow, it also makes sense, there is a business pressure to keep the transaction cost low, so we need to be efficient than the previous years as well. That's also one of the drivers. And without telling any of you, always on and be secure. That's a requisite for making sure that we are operating one of the top payment solution in the world. And based on the scale which you have seen from the previous slide, we cannot operate things manually. We have to have a touchless fleet management system. So most of the stuff which we do, we need to have a touchless fleet management to scale. The last piece which we have added in recent years is, as with the central teams kind of started to decentralize on some of the aspects of the cloud management, application management, the site management, we wanted to make sure that PayPal as a business is getting the benefit of the agility coming from DevOps by decentralizing some of the central functions. So that is the latest addition to the cloud strategy, that we are enabling DevOps through some of the self-servicing capabilities. So that's the context of this meeting. So any drivers which contributing to an overall PayPal cloud strategy is getting evaluated on a regular basis as a continuous improvement on these strategies. And the drivers are majorly this. So coming to the DevOps. So DevOps is not just a word, it's a behavior. And the behaviors are associated with the different parties involved in the DevOps transformation of any organization, right? So for us, mostly the DevOps started with end-to-end accountability. So earlier, if you look at, I was a part of the development team earlier. I was not a part of the infrastructure team. So the mindset was, you develop the code, you develop your package, and build the application out, release the code into a repository. Someone else will take that code and release to production and run it in production at scale. So it was pretty straightforward. You develop the code, check in, build will happen, some others will test it, somebody else will take it to production, run it at a scale, right? And developer, your job role ends at that part when you do the check-in and make sure that the P1, P0, P1 bugs are fixed. So it was never going beyond that, and the developers were not really getting into how the site operates. So that was not driving the right behavior in terms of agility, in terms of what is the feedback coming from the site and whatnot. So that was one of the business problems which we are trying to solve through the DevOps. And that's where it is very clearly called out that DevOps, we wanted to drive end-to-end accountability across the team. So if somebody is owning a service, that is not only the development is owned by that team, the operations, monitoring, upkeeping of the service, everything is owned by that team. So we wanted to drive that accountability. Second thing is allowing the flexibility by providing right set of easy to use tools for them, right? So right set of easy to use. So it's very easy to make a statement that, hey, give the end-to-end accountability to all people in PayPal, but without giving the right set of easy to use tools. So the right set of tools is one definition, easy to use is another definition. So it should be very transparent to the end users that when whatever we are providing, it should be very easy to use. That was another principle which we kind of told, that allowing flexibility to the end users to decide on their applications by providing easy to use tools. And so some of the teams might choose to go on their own path for building some of these tools, but overall we have close to around 450 Scrum teams in PayPal, which means that if the teams are going on their own ways to create these tools, and if there are no contracts between those applications or those tools, it may not be operated based on a common understanding, right? So create a framework where there is a service, there is a contract on the service expectations and establish the standards across the organization. That was also a part of the DevOps journey. And making sure that there are defined policies exist, but at the same time, if any teams wants to adopt a new technology for getting their results faster, enable them, allow them to use that new technologies, but still be within that policies. So we will not take a rigid stance that, hey, you should use this tool, you should use a specific tool or service, but at the same time, stick to the policies. If you are coming with a new tool, it's okay. We should allow that, we should be democratic about it, but at the same time, ask them to make sure that it's sticking to the policies which we have. Those are the parts where what DevOps is for PayPal as defined, and what DevOps is not is, I mentioned about we have close to around 450 teams, Scrum teams. Think about each of these teams are going to come and create their own tools for provisioning, patching, and whatnot, vulnerability management. PayPal will have, each of the teams will come up with their own tool, and it will be a tool shop, not a payment shop anymore, right? So we definitely wanted to avoid that, to have multiple teams writing and reinventing the wheel for the same problem. So we were very specific about we'll not make that happen in PayPal. So another thing which we were very clear about is it will not be forced on the teams, and that's where I was mentioning earlier about allowing the flexibility and connecting that with easy to use tools. So instead of a push to use something, it will be a pull. So that's also was wanted to make sure it will be never forced onto the teams that you should do DevOps. Then the last one is a finite set of tools. That was not the goal. So the teams can expand on their own tool set, but at the same time be within the guidelines which we are looking at. Any questions on this slide? Okay. Sure.
Who does the governance of the DevOps?
So the question here is who does the governance of DevOps, right? So by the principle of DevOps, there should not be any governance. But the policies and the policies which is defined by for the operations and the contractual teams, that was a core committee. There was a DevOps core committee, and there were representatives from multiple teams involved. Like so PayPal is having multiple BUs like merchants, consumer, payments, risk. So there will be representations from that. And when these policies or these tools are getting developed, their involvement and the discovery of those were definitely taken care of. But by the definition of DevOps, governance needs to be done by that specific team. So they are responsible by their upkeep of the system. They are responsible for security patching of their system. They are responsible for monitoring their system. So governance, that's empowering those developers to govern themselves, is the part of the DevOps.
So use two terms up to here. One was apps, or there's 3,500 applications.
Yeah.
I'm wondering if you define what constitutes an app for PayPal. And then you also use the term end user for these teams. So I'm wondering if you could elaborate on who the end users are for these teams.
Okay. So the application in PayPal, so you type in www.paypal.com. So you'll see a nice user interface where it will show the login, and that's where we can enter your username and password. So that is an application, and that application you can think about like close to 2 million hits will be there at a time for that application, right? So that is one application, you can think about that. And you click on login, that application calls downstream service and pass on that username and password to authenticate that user. So the authentication will happen in say another 10 layers or 15 layers, which is microservices distributed applications. So each of those applications, there is a risk verification happens, whether this person is trying to log in from the same IP, those kind of, each of these applications are different. So that's why it's microservices, that's why the number of applications are high. Its application is a boundary where we define that a specific set of nouns and verbs are matched for making sure that a functionality is complete. That's the application. So did that explain well?
Yeah, I think so.
Okay.
How they're compartmentalized also, I guess.
Yeah, that's right. Yeah.
Just to add to it, it is web applications, you have services, you have batch, and then these are the different types of.
Yeah, we also have we have different type of tiering, like the web tiering, mid tiering, backend, OCC. OCC means is a kind of connecting to the databases, different tiers, and each of these tiers, the stack which you are using is different. Yeah. Second part of the question was related to end user. So the end user, in this context, the end user is the 4,000 PayPal developers. So we have close to the 3,500 applications are written by those 4,000 plus engineers, right? And they're distributed across the globe. PayPal is having close to around 30 plus application development centers across the globe. And those are the end users of these systems and applications to release the code into production. So here, in this context, in DevOps context, end user means the application developers. Okay.
But the infrastructure serves about 230 million users.
Yeah, PayPal user base is around 230 million users. This is the users of DevOps is within PayPal. That's like 4,000 plus engineers, right? So any organization, if you guys are planning to do DevOps in your teams, you should also ask these questions. Yes, DevOps is a buzzword. Should I do it for my organization, right? So, and what what is there for PayPal from a DevOps program perspective is the question which we are trying to answer, right? So for PayPal, the availability and security are the required ones to be continued to be met all the time. There is no ifs and buts about availability and security. It's a must, it's a baseline. And on top of that, our purpose for the DevOps is geared towards velocity and the quality. And so that quality where is coming from that testing and pre-testing and releasing before releasing into the masses, do a minimal runs and whatnot, right? So major drivers, the key drivers for PayPal to invest on DevOps is the velocity and quality on top of availability and security, which is expected minimum, right? Our gaps were in the velocity and quality. And definitely we had, so once we decided on this path that velocity and quality is the reason why PayPal is doing the DevOps, we also invested on availability on security during the journey, because that's what we live in for, right? Making the safe payments work for everybody. So now, getting a little bit more into what are the intent focus areas for the DevOps in PayPal. So if you can look at this slide, we have multiple areas where the DevOps could have focused. DevOps can happen, say, in continuous planning. So we can plan better, define the boundaries of a product in a precise manner. That's a place where we can do the DevOps and make sure that full autonomicity is given to a team. Continuous quality, this is where, sir, your question come in later, in the earlier time, about the continuous quality, like unit testing, changes, and whatnot. So that's an area where we can embrace DevOps more. Or continuous deployment is another area where we can make sure that there is a check-in with the pipeline, it goes to the next layer until it gets released. Continuous integration, another one. Continuous operations. Continuous operations means monitoring the site on a regular basis by signals from the systems and making sure that taking actions based on that and feed into the remediations of the site faster. And definitely a lot of investment on people and culture. That also is needed for defining the right behaviors from the DevOps perspective. So what we chose to do is select some of the areas where we need to have deliberate investments and select some of the areas where we'll be organically anyway progressing, right? So we chose to do that in two paths, like a deliberate investment in some key areas where we thought that is a must for us to do as PayPal, and organic investment for some of the areas where it's already getting done, so piggyback on that. So in 2018, very specifically, we were much more focused on the vulnerability management, like patching of the system. Think about going back to the first slide which I presented. We have close to around 240,000 VMs and 70,000 bare metals. And the patching of that was done by a central team. And think about their pain of getting through all the patching by taking the boxes out of traffic, getting the right set of time for the patching and whatnot. And think about if we can unleash the power of all the 4,000 plus engineers in PayPal, we can achieve a greater velocity in patching. So think about we were doing the patching of the site, say, once in 3 months. With the distributed and democratizing the patching, we'll be able to get that in, say, 1 month. So it means that we are reducing the vulnerability on the site by every minute if you're trying to do that, right? So that's one of the reasons why we chose vulnerability management as one of the goals for the DevOps. Other piece which we focused on is the self-service provisioning and like the application provisioning or the VM provisioning, bare metal provisioning, all those kind of things. I'll little bit deep dive into those areas and explain how it was done, right? And you need to think about these pieces were done by central teams who had very deep knowledge about their areas. If it is a security operations engineer, that person knows inside out about the patching. What is meant by patching, where the patches are coming from. It's coming from Canonical, Red Hat, Ubuntu, and whatnot, right? But when we are giving into a set of engineers who never patched a box in their life, we have to we need to still make that operation successful without risking the site availability. So those are the challenges which we faced when we really give these self-services features to others. And the principles where we went back to those principles, right? The principles were easy to use was major principle, and so that the adoptions will be faster. So with that, okay. So with that, these are again a recap of we chose the vulnerability management and the self-service provisioning as the big areas to focus on, along with the monitoring also we kind of invested a little bit. So for infrastructure self-service provisioning, we wanted to have the quota management. Okay, I can read all the 5, right? So the first one on the left side is the quota management. For the infrastructure provisioning, the thing which I'll go back to the old question which I had, right? Are we on-prem or in public cloud? In on-prem systems, the reality is you cannot get unlimited quantity of compute or resources. So you have to have a quota. So if you're going to think about you're going to give a self-service provisioning capability for 4,000 people, we need to limit that using a quota management. So a specific application, we have 3,500 application. A specific application might get, say, 100 CPUs or 1,000 CPUs. They should not be exceeding that quota. That's the first part. So for doing a self-service provisioning, we need to have a quota management. That's the left side, the quota management and the infrastructure provisioning. Monitoring, incident management based on the monitoring. If there is an issue happening in the area which a developer is owning, we should be able to send from a platform side, we should be able to give them enough visibility into what is failing for enabling them to make it triage in a better way. So I'll show some screenshot about how we achieved all those kind of things, right? Security operations is again the patching part of it. So those are the 5 pillars we chose to invest. And I will go one by one. The first one was, again, the self-service patching. So this is a UI which we developed. And this is where we developed multiple features for enabling self-service patching, right? Patching, think about patch, so out of the 240,000 VMs, if you need to take a VM down for patching, we need to take it out of the traffic first. So that's where you'll see something called ECV in and out. It's electronic content verification in and out. It means that it's not going to take any traffic if it is ECV out. Pause that, we need to patch. Pause the patching, we need to start the application, and then put that back into ECV. So this is a simple process, it may look like, but somebody who never did that, it's a very daunting thing to do, because taking out of traffic, put a patch, put it back to traffic and whatnot. So this is a very easy task for a system administrator or a systems engineer, but for the developers, it's not that easy to do that because they never did it. So this is one VM, and it will show that here you will see that it shows as vulnerable, right? It's running a 4.15 kernel in Ubuntu 16.04. The reason why it is showing as vulnerable because we released a new patch for it. So when Canonical release a new patch, we take that patch, certify it in PayPal, and publish that patch. When we publish it, the developers who are using that image for their VMs, they will see that it's vulnerable, and they'll need to go and patch it. So they can access all these functionalities using APIs. If they want, they can write automation also for patching. So this is just a very high-level view about the patching. So my point here is DevOps is just not only a behavior. I told earlier that DevOps is a behavior. It's not only a behavior. We also need to provide tools, easy to use tools for making the adoption happen, and people are using and have a higher flexibility and agility with that. So another feature which we enabled is self-service provisioning. So this is like we introduced a Uber level orchestration layer called PayPal Cloud Services. And obviously the teams wanted VMs to be provisioned, bare metals to be provisioned, storage to be provisioned, LB operations. LB operations are like create VIP, add and remove members to the VIP, enable, disable members, network operations, create firewall rules and whatnot. So this is not, some part of this journey is not complete, only probably around 70-80% of this journey is complete. So this is a very high level overview about. Think about all these operations were done earlier based on tickets, and somebody will need to file a ticket to get it done. And so we provided easy to use self-service tool for achieving those things. This is just an example of provisioning of a VM in one of the projects. So here you'll see this is a project, and there is an option to provision VM in a specific availability zone. So I mentioned about the quota earlier. So this project is having a quota of around 5,000 vCPUs. So they can create VMs of different flavors up to 5,000 vCPUs. And this team is already used 272 vCPUs out of that, and 4,700 is remaining. So this will also make sure that the end user teams are using their resources effectively. And if any of the resources are not going to be used, they will not provision it. And if they want to rotate and they want to delete some of the unused ones, they will go and delete. So once they reach their quota limit, they will need to go back and clean up whatever is not used. So it will also drive the efficiency. Going back to my earlier slide, there is a cost efficiency, a cloud economics angle to that as well. So this also here, you will see only a specific set of users can access these VMs based on an IAM role, right? So it's also very secure that only that set of people can access the box and do any operations on that. This is just an expansion of how the self-service was enabled. They can choose the network that is a VPC. They can choose the flavor and create the VMs. The VM will be getting created. So this is, again, this is one example of VM. And similarly, they can create the VIP. So create a VIP, and that VIP can have multiple members into that, VIP definitions and whatnot. So from us, and we have similar stories for bare metal as a service. Bare metal, they can provision themselves. And application provisioning using another tool called Altus in PayPal. So there are several of these operations. Normally, they have to do the tickets. We encapsulated that using the DevOps framework. And the PCS, the PayPal Cloud Services, we enabled that DevOps journey for PayPal. So the last piece which I wanted to cover today is related to the self-service monitoring, right? This is in existence for some time. The reason why this is really important is in the previous slide, one of the previous slide I showed, we have an infrastructure provisioning, quota management, and there is an incident management angle of the DevOps where the full accountability is given to some of the teams, like the development teams, right? If the full accountability is given, it means that the team is owning both the development and operations. And for owning the operation, they need to have an eye into what's happening in the site. So this is a system which it provides the visibility of that application, how it is performing in the site. So look at from the left to right. This is a daily behavior of this application. You will see ups and downs. It's based on the peaks of the day. It's a pure internet traffic pattern for any applications in PayPal or any applications in the internet. You will see here, this is an interesting behavior, that there is a failed service interaction for this service at this specific time, right? So suppose there was like 10,000 requests for that application, but on that time, around 0.01% of the request came into that application failed. So it's 0.01, it may look like it's not big, but 0.01, when we look at 32 million hits for that application, is a big number, right? That many users will be impacted. So here, what would have happened is, this incident would have triggered a PagerDuty alert to the on-call of that PD, that developer, development team, and that person would have got a call, what happened. So, but if you're looking purely from this incident perspective, this looks like this could have been auto-remediated because it was a spike, it came back right after that. So there is an auto-remediation aspect of it, but at the same time, what the developer would have done is, they would have went back to the application, looked at what happened on that time, do a proper postmortem, and feed back into their product backlog. So this framework of providing the self-service for patching, providing the self-service for provisioning, providing the self-service for monitoring, it kind of gives PayPal in a good trajectory to get into the DevOps model. And definitely we had a lot of challenges throughout this journey, right? Majority, so I have listed out a lot of the patching challenges here, but think about earlier, all these operations were done by one central team. Think about that team size is say 50. So the access is limited to that 50 people. Right now, the access is went to 4,000 people, but not all the 4,000 engineers are getting the access to the whole site. They get their project's access, right? So we have to deconstruct every access pattern models to fit into an IAM role, divide that into projects. So it's not only providing the tools, thinking behind it on how to deconstruct all the site into small pieces and assign those projects into multiple, that's also is there, right? And introducing least permission model, which is very good for the security analysis in future. I mentioned this earlier, patching moved from a script which is being run by a sysadmin or a systems engineer. We moved that as a service, and the service is consumed at a higher level by an API or a UI, right? There are places where patching or any operations will fail on a box, and at that point of time, most of the developers does not know why the patching failed. So it's not fair to tell them, go ahead and try to repair the box. So instead, we should provide an option for them to replace that box. It pushed the boundaries of the program that we went ahead and did more to do that, expand the scope. Definitely alert based on the incident, UI developments from the patches, provisioning, monitoring insights, how SLAs are met, other things, right? Traffic management was another part. Even though it was not in the scope, we had to do that for meeting other goals. So from a overall conclusion, PayPal will continue to invest on other areas where we haven't invested, like mostly more into the monitoring, more into the incident management and problem management space, and bring all the teams together. So what really worked for us is we picked some of the common places based on the big problems which we wanted to address and big risk areas where we wanted to address. That was the intense focus area which I covered earlier. It is working for us. And my recommendation to you for anybody who's starting on the DevOps journey will be really do an analysis on your problem statement, what you really want to achieve in your organization. Pick a place to start with that problem statement in mind, and that need not to be the biggest problem which you need to solve. Pick a place and start immediately. That's, yeah.
So, can you explain about the scaling process, like scale up, scale down, and also like load balancing?
Yeah. So the question here is the elastic capacity management, scale up and scale down of the applications, and the load balancing management. So I'll get to the second part later, but I'll start with the scaling up. So you have seen the PayPal scale, right, around 240,000 VMs, and we recently started moving into containers with Mesos cluster behind it. Think about during the peak of the year, right? Peak of the year for us is generally in November, when a lot more transactions are happening in the site. And a general peak is like an internet traffic every Monday from 9 a.m. to 3 p.m. That is the peakest day in a week for the internet traffic. So based on the growth of the business, PayPal business is growing like 20% year over year, and the infrastructure is growing probably 20 to 30% year over year. So for some of the applications, based on the application's characteristics and application usage in the site, it will need scale up mostly. Scale down is very rare. The reason why the scale down is very rare, especially with the on-prem, is we already bought that capacity. There is no point in scaling down because the capacity is already there, right? So, but when we are going to the public cloud, it makes sense to scale up and scale down. So we developed systems, we call it as auto remediation systems, which looks at the traffic patterns, and we have a lot of data. Our data goes back like many years, right? So we know exactly April 3rd week, Monday in 2018, the 9 a.m. to 9 p.m. traffic pattern was this. So we'll go back a couple of years. We'll go back a couple of Mondays back. We'll look at the traffic pattern. We'll tell that this application will need these many boxes to handle the capacity. So that's the ML-based algorithm which we have at the back end. So all this data is available in Hadoop clusters. So there is a deep machine learning applied to get into a place where, hey, this application, as I mentioned earlier, one of the applications is that when you type in www.paypal.com, that is the biggest hit application, right, from an outside in. It's called as Hermes Node Web login page. And that application, say, it needs 2,000 boxes. So that will be based on a machine learning and how much per box, how much transaction can handle in one box, right? So suppose if you're going to have at Monday 9 a.m., we're going to have, say, 2 million hits. 2 million hits means it will be translated into transaction per second, how much transaction we are expecting per second from that application and translate that into number of VMs. It may come down to say 2000 VM. And suppose for that application, we are at 1800 VMs, we will flex up 200 VMs more for that application. So it's a predictive analysis based on the historical data, machine learning, and there is a manual element to it by telling, say, for example, eBay is going to run a promotion in eBay site, and the PayPal traffic will increase. So we'll get that inputs as well from external inputs, external manual inputs as well. For example, Super Bowl is going. So February Super Bowl is there, right? We'll get those kind of information. We'll tell that on that Sunday we'll have higher traffic, and the number should be 2x compared to last Sunday. We incorporate that into our system, and the system will auto-flex these boxes. And post that incident, post that event, will scale down as well, because it will be.
This is very dynamic, it's not without a manual event, right?
Yeah, so that events, right? Events like the public events, or eBay is doing a promotion, or some other merchant is doing a promotion, that is manual. But what is not manual is the historical growth. So we have a rich data over the last many, many years. We'll decide the organic growth based on that. So there is no manual involvement there. Yeah.
So that description sounded like it takes a lot of lead time to spin up boxes, to spin up new computers, as opposed to saying we're always going to have 200 computers more than our current load or something, and spinning them up.
Yeah.
Right.
Yeah. So basically, that's one of the reasons we are going to move away from the VM into containers. So what we do there is, instead of a VM-based application model, we are going into the containers, right? So cluster-based containers. We'll create a gigantic cluster, and say one application needs 10 more boxes with a new platform called Genesis. It's pretty fast. We can get 20 containers up in less than 5 minutes. So with the Mesos cluster, and future we'll be using Kubernetes, we will be able to achieve our flex up very faster than what we are in VMs today. Yes. So that lead time is there for the VMs, but generally we do pretty good job. We should be able to flex up within like a couple of hours, whatever the flex up which we need.
It is not days or weeks.
Yeah. It's not days or weeks.
Earlier it was.
So the DevOps journey, obviously you're in this DevOps journey and you've gone through the maturity quite a bit. You're probably 80% there, whatever, based on what I'm seeing. How long did it take?
So
And what are some of the major roadblocks that you encountered in it?
Okay. So the question here is, how long the DevOps journey in PayPal took for us, and what are the major roadblocks we faced? So we had different versions of DevOps, right? So the first version of DevOps was, can we give, so earlier when you need to create an application in PayPal, you have to file a ticket. So and that ticket, there is an architecture review, there is a port, there was reviews like you need to assign a port to that application that takes multiple port, 30847, that's the port which this application will listen, and that port allocation will take weeks. So this is just I'm just giving an example, right? So application creation itself was taking 3 months. That was the state where we are at some point of time. And for getting a check-in propagated into a staging system was 3 days, 4 days. That was another set of things, right? And running your tests, and PayPal is always had very good automation built around it. and running the automation, say you made a check-in and you need to run mini regression, gold regression, silver regression, whatnot. If you need to run, say, 15,000 tests, it used to take 3 days to run the test. So that's very contextual, right? The question is very contextual. So I would call it took, so we started the real DevOps journey somewhere in 2015 as a part of the split. And in the maturity where we are, we still believe that we are not at the right level of maturity, even now, in that journey, right? So we are probably spent close to 4 years now, 3.5 years now. And we have, in lot of places, we have high level of maturity in terms of DevOps, but in some places we have zero maturity. So I would call, it's not even 80, probably I would call 60, 70% maturity therein. Right? It took that kind of time. It's not easy to do that. You had a second question?
Roadblocks.
Yeah, so most of the roadblocks were, in fact, when we designed these projects, we did a lot of discovery with the end user teams. And the end user teams were like the developers were really helpful in forming these things, right? So there was a buy-in of why you are doing it. Think about you file a ticket for an application creation and wait for 3 months. So, and if somebody is trying to automate that, what will be the buy-in? So there is no roadblock from a cultural perspective because everybody wants to get things faster, right? So most of our roadblocks were, did we have the right cloud behind for making the DevOps happen? Did we have the right tool set? Did we have the right security practices? Do we have the right behaviors associated with some of the users? Those are the very high level roadblocks. And definitely the investments, we invested a lot on all these journeys. So that's pretty much some of the challenges.
So from a leadership, organization, and cultural perspective, there weren't any roadblocks there?
This was sponsored by the leadership in a way. So this is like, think about where you check in something today and that code goes live in production after 3 months. What is your velocity? What are we talking about? So it's already impacted our business. So there was no question about the resistance in the ecosystem. So that was pretty evident. Yeah. Yes. Yeah.
So with self-service distributed patching, how do you ensure that systems are actually getting patched?
Okay. I just want to go back to one slide. Okay. So there is, patching is a verb associated with a noun, VM, or bare metal, right? So that's one type of operation. Provisioning is a verb, patching is a verb, reboot is a verb, multiple verbs are there. Application deployment is a verb associated with a VM. So whenever you are doing an activity on a noun, it goes from one state to another state. So you do the patching. Before doing the patching, the box was in a vulnerable state. That's why here the box is in vulnerable state, right? You apply the patch, the box will move into another state where there is no status of the vulnerability. So this is one way to represent this, that this box is not anymore vulnerable. And there are scanners deployed by the security engineering team to go through all the 240,000 VMs on a regular basis. They scan it and they match it with a database which is stood up by them to see the patches which got released is applied into those boxes. It's a one-on-one matching. Whether the box should be like this, what it should be, whether the box is like that. So there is a scanning. And the scanning tools, we had our own scanning tools. The latest one which we are using is a NESUS scanner, NESSUS. That's the scanner which we are using. And we use the Qualys also to make sure that there is a continuous report coming in to all of us. If we own any VMs, there will be continuous report coming to us that your VMs are vulnerable or not.
So the owners of the VMs, they get notified?
They'll get notified, or when they go to this tool, they'll see that your VM is vulnerable. They'll need to apply the patch.
So, a couple of times you've mentioned that one of the goals of things is to have the tools be easy to use. That's subjective. How do you measure that?
So the question here is, there was mention about the easy to use for the self-service tools, right? How do we measure the success of that part? So there is only one way to measure that, the seeking the feedback from the end users, right? So there was a good enough discovery done before we define these projects, define these requirements. So there are product managers assigned for these products. So they do the discovery with a set of people, and post the release as a part of the acceptance criteria for these products. We definitely involve some of the end users, not all the 4,000, but some of the end users, and ask them how the usage of this and whatnot. So it's a subjective feedback coming from them on the easiness of use.
Well, that's right.
Yeah. So basically,
Horizontal or whatever, is it,
yeah.
does it make that harder?
Yeah. The question here is, the development teams will be in multiple release cycles, and when they patch will be on different timelines, and whether there is a chance of having drift in the environment in the kernel versions and whatnot, because the timelines are different. Yes, we are fully aware about that. Very good point. So what we did is, again, this is not fully implemented. When we started the journey, we were like maybe once in a quarter we get things patched, right? That's where the baseline is, and we are trying to get into a place where we patch everything within 30 days. That's the goal, and 30-day patching cycle. So within that 30 days, the drift really doesn't make a lot of difference because we are already at 90 days. There's a lot of drift happening. So the drift will always happen because the cycle of the application, A getting patched is not the same same time the application B is getting patched. So there is no way to eliminate that drift. It will be there in the system, but what we make sure is when we are releasing a patch, we make sure from a platform side there is no performance or latency or any other implications for the applications during that time. So if you observe the other graph which we had, there is a performance graph for the application, right? If we release a patch which can impact the latency of a specific application, because like it's improved latency or reduced latency, whatever it is, right? For the improved is good, for the reduced is bad. So we will, but it doesn't really, so based on the testing of the patches, we make sure that bad patch never goes to live for patching. So the baseline and the new patch will be always better. So we don't really care about the drift a lot from an availability and performance perspective. So yes, drift will be always there for the last fleet. Okay. Sure.
One more. The self-service of provisioning, have you also experienced where resources are spun up and not reclaimed?
Yeah. So this is a,
Especially with, as developers
Yeah, the question here is if the provisioning is done, but if the boxes are not used, are we doing anything about it? Did we observe this kind of behaviors? Absolutely yes. So both in dev as well as in prod, we have an efficiency issue, and our efficiency numbers are not that great. It's still in 90s, but it's not near to 100, right? The efficiency. Efficiency means there is a IAS level efficiency where we allocate vCPUs for application, and there is a traffic level efficiency, whether that all CPUs or the VMs are getting used for the traffic, whether it's getting enabled in traffic or not, whatnot. And even if it's enabled in traffic, what is the load in that boxes? Is that like 5%, 10%, 15%? So we have checks and balances in each of these layers, the CPU utilization, then the traffic utilization. So there are programs associated with reclaiming those capacity if it is not getting used, and that the spend there for any organization, not only for PayPal, reclaiming the boxes, the spend is always provides a good ROI, because as we firmly believe that there will be room for creating that errored VMs, or people are not being very focused on the provisioning meets their needs, or over provisioning and whatnot, right? So there is an efficiency program running. Some of them are automated, some of them are manual. But the point is very valid. This will happen, especially with democratizing the provisioning. This happened, and this continues to happen. So we have reclamation systems in place, looking at the traffic and other patterns. Okay. Cool. Thanks a lot.